All right. So the first two questions are pretty much the same thing. One is a trig function, one is a power function. Doesn't matter. It will be approached exactly the same. So we'll just do number one, I guess. So we said when it was on a interval, that we'll find the critical points and then plug in the n values, right? That's what we've been doing. So let's start with the criticals. Now, once we find them, all we got to do is plug those into the original function and see what is the biggest one, what is the smallest one. So let me write here exam 3, right? Yeah, exam 3. Find the absolute extreme values. On the interval. Yeah, well, as soon as I write it down. I was writing that question first, then I'll switch.
Negative 27?
Yeah. Negative 27.
Yeah, that's hard.
All right, well,
So where are the multiple guess? I mean, the multiple choice.
oh, they're in there, but it doesn't matter. I don't look at that stuff anyway. I don't really care what you choose. You can leave it blank if you want. What matters is what you wrote down.
Is that 4/3?
4/3, yeah. Okay. Well, that doesn't look too bad. So 4/3, what is the derivative of this guy? See. Yeah, looks like it. Bring down the 4/3. So 4/3 minus 1, that's going to be positive. So that'll be 20. Okay. Yeah, that's right.
Calculators took a long time. to look.
That's funny. Okay. So how do you find critical numbers? What have we been doing? Yeah, set the derivative, right? So find the critical values. So set. So that gives us 20/3 x to the 1/3 equal to 0. There's only one number that's going to make it 0. So at this point, so now test x equals negative 27, 0, and 8 by plugging them into f. The largest value will be the maximum. The smallest value will be the minimum. So super easy, right? Plug them in and see what they are. Nothing crazy.
Oh, I remember. So I was curious about this.
Yeah, that's I think very beginning of chapter 4, I think. So f of negative 27 f of 0. I don't know what these numbers are, but figure it out, I guess. I'll do the hard one. What are the other ones?
Negative 27 is 405.
The
Zero,
final result,
zero. Yes.
405.
And 8 is
80?
yes.
Okay. So maximum at negative 27, 405. Minimum at 0, 0. Any questions on number 1? You'll for sure have something like this, something similar. Okay. Now, if you were to graph it, you would see this would be one of the biggest value and the smallest. Any questions on number 1? Is it okay? Let me know. Number 2 is the same deal. You take a derivative and then find the critical value, whatever, who cares? 3 and 4 is all it wants you to do is find the critical, but it's going to require a quotient rule. Or you can force a product with a chain rule if you want to avoid quotient. Whatever you prefer. You guys cool on this page? Oh, wait a little. Oh, wait a bit. Okay. Next page. So number 3, I suppose. Determine all critical values. Is that better?
Yes, thank you.
Yeah. Okay. Let's switch over. I always forget which one goes first because I prefer the product rule.
X times F prime minus F of X times G prime over G squared.
The G is first. There. Okay. Thanks. Personally, I would have used product, but I think this will be better.
Remember, so you talked about the quotient, you're always saying which one comes first? Which one you're talking about? You're talking about between G and F? And then first top?
Which one's being subtracted? Like, is this one in the front? Oh, well, I'll show you in a second.
Because to me, I see it as the product rule on top, it's just a subtraction.
Well, in my mind, the product rule is just the derivative of one of them times the other plus the derivative of the other one times the other one. So it's just switch. So the order doesn't matter. So I don't memorize the product, but the quotient requires a specific order. So this one needs to be first.
So you're talking about which one you take the derivative of, that you take.
Yeah. So which one has the minus? So I always forget, and it's just because I'm being lazy. Anyway, okay. That'll be x plus 2 times -6 minus -6 times 1 over x plus 2 squared. Okay, minus minus is a plus. Distribute your negative. That'll be -6x minus 12 plus 6x. So these are gone. So the derivative is simply -12 over x plus 2 squared. Huh. That's funny. I don't think there's any critical values.
I don't know the X plus twos.
Yeah. That's it. I'm pretty sure there's no critical values. Let's go find out. Let's check the answer. No critical point. You guys see why?
It's in a function and not an actual.
Well, it's because, oh,
You said it's a zero.
yeah, to find critical values, right? You got to set them to 0, and this will never be 0. So if you even, let's try it, right?
This is the numerator, you have to be able to set the numerator to 0. So the denominator doesn't matter.
Basically. The denominator only matters if it was defined in the original, but not in the new one. But they were both undefined at -2, right? It was not going to happen. So it stayed there in the derivative. So no solution. Because there is no value that makes it 0. Any question on number 3? Does that make sense? Four will be similar. There might actually be values though. Not if you see anything about mean value theorem, feel free to skip those. I'll probably make those like extra credit or something. Don't waste your time on mean value when you start the exam. Okay, don't forget. Number 6, the good one. Use the derivative of f of x to determine the intervals of increasing / decreasing. Okay, keep it short. Hey, they were nice enough to give us a derivative. How cool is that? So try to shorten it up a little bit. Use the derivative of f to determine the intervals of increasing, decreasing. Okay. So to figure out the intervals, we need to test around the critical values, right? So set this to 0. It's already a derivative. When is this 0? Since it's already factored, you can simply just set each piece to 0.
X plus X equals 6 is 1.
Yeah. It's an ugly 6.
But you don't question, when you have exponents, just X equals 0, right?
The only way this will be 0 would be if x is 0.
Okay.
But you could cube both sides. 0 cubed is 0, right?
Yeah.
To cancel the third. All right. So just test around them and we're good. Here's 0. Now here's 6. Pick whatever you want. Into the derivative. So test around the critical values.
-2, 2, and 8.
-2, 2, 8. Just cuts. The derivative at -2 will be -2 to the 1/3 times -2 minus 6. The only thing that matters is is this negative? Yes. If you want the number, just plug it in, right? F prime at 2. Ooh, actually, negatives plus. This will be negative. That's -2 times -8, which is a +8. 2 times -4 is a -8. Wait, that's not true. Sorry. That's fake. Fake math.
On that first the cube root, we take the cube root of a -2. And we then imagine that, put the negative number right underneath the-
You are
-6, but
what's that?
-6, but close enough.
Well, the 1/3 is going to give you a decimal. So it's not going to be pretty. The last one will be though. Were you talking about the last one?
No. just- First one's 10-ish.
10 point something?
I'm not being too accurate. You're confusing crap. out of me.
Why? What'd I do? Sorry.
Because maybe it's this, no, maybe. This and this, no, wait. Second one is 5-ish,
Five-ish.
negative 5-ish.
Negative is what matters. The number doesn't matter. Doesn't matter. So minus, that's what I wanted to know. The last one is positive, right? 4, is that right? 4-ish? Just kidding.
Alright, wait, hold on, screw it.
Should be 4 exactly.
It's about 4.
4? Cool. So 10 something, -5 something, 4. Numbers, who cares? Now, where are we increasing?
So if you're increasing, you go down, right?
What do you mean by down?
Increasing from
Yep.
and from 8 positive, it's decreasing from 0 to 6.
0 to 6, right? Decreasing union 6 till infinity.
Oh, no, 8. Oh, wait, yeah, 6 to, my bad.
Yeah, we gotta use the critical. Any questions on this end part here? Does it make sense?
Just trying to work out how, if we take the square root of a negative number, it becomes imaginary.
And
We'll work out.
only even roots have that problem. Square, 4th, 6th, 8th roots. Odd roots do not have that problem. So
I guess what I'm saying is that if I take the square root of the -2.
that
it
would
give
be
me like an error,
imaginary, yes.
but if I take -2 to the 1/2 power,
That would also be a problem, yeah. Same problem. But this is a cube root.
because I'm putting it in the power.
Put it in a cube root. We don't have a square root.
So I put the negative times the 1/2.
Any other questions on this? Okay, 7 is the same thing. They just, you'll just have to do a quotient rule. That's about it. Number 8 is find the point of inflection. So that means we have to do 2 derivatives. Set it to 0, and that answer will be the inflection point. You guys cool on that last page? You weren't good?
I was gonna understand, I was small.
Find the point dang it. Of inflection. So what is the first derivative of sine? Yeah. What's the derivative of cosine?
Is it negative sign?
Yes. Okay. When is negative sine 0 on this interval? Sure.
The way they write it is so weird compared to like how you make it make more sense.
Yeah, I'm just trying to translate it. Find the point of inflection on the graph of the function. They don't exist, type D and E. Okay. So to find a point of inflection, set this to 0, right? So when is sine 0 on your unit circle? Yeah, pi and 0. So x is equal to 0 and pi. You plug that in, you'll get 0. Just from the unit circle. So you look at the circle and you'll see when sine is 0.
Does it matter if it's negative sign now?
Nope, because you can solve for sine, right? If you divide both sides by negative, you get to here.
Just curious.
That's a good question. This is why it doesn't matter. Now let's look at the answer. Yeah, there it is. Pi and 0. Any questions on number 8? There's not much to do. You just take two derivatives and then find out when it is zero. That's how you find inflection points.
Zero and pi though. If I get the pi part, why is it zero?
There's two locations. Let's look at the circle. Let's find our circle, all right?
You record on this one, right? This,
What's up?
this will pop up, record this.
Yeah, it's on. So sine is the y value, right? So at 0, we have a y value of 0. At pi, we have another y value at 0. There's only those two locations that you have y's of 0. So both of those are within 0 to pi. So those are your solutions.
I needed a little.
It's okay. Any other questions on 8? It's not too bad, right? Number 9, L'Hopital's rule. So L'Hopital basically, you can use that whenever you have 0 over 0 as your limit, or infinity over infinity. Do you agree that if I take the limit, you have infinity on the top and infinity on the bottom, right? And then things will begin to cancel, right? You write the question down. Find the limit using L'Hopital's rule.
Without using.
Oh, without. See, I can't read, man. All right.
Pretty was making it harder for his leg, man. No one says. I mean, making it easy.
No, I have a bad habit of skimming things. My boss gets really mad about that. Okay. Oops, forgot to write it down. Alrighty. At least you guys are paying attention, because apparently I'm not. Honestly, there's a couple ways we can do this. You can divide everything by the highest power, or you can just say, well, the degree of the bottom is bigger, so
I was gonna say, is this where those rules came in that you taught us, where if like the numerator is bigger, then it's like 1 or something, the denominator is bigger, then it's 0?
yes. So it's 0. So now I would just explain that, and you're good. The degree on the bottom is growing faster, so it's 0. Or you can show the rule, the actual work, like we did back in chapter 2.
For those rules, if it's every comment is 0, higher than 0.
It's infinite. Infinite if it's bigger on top, 0 if it's bigger on bottom. If they are the same, you divide the leading coefficient of the top and the bottom. Those were the three rules I gave you.
And that's for the, that's only, is that for the horizontal asymptote? or something?
It is related to the horizontal, yeah. That number you get when you divide the leading coefficients is the horizontal asymptote. I'm sorry, oblique asymptote. Horizontal is when horizontal.
It's not that. Oh, it's like the same rules, like, same rules you just said right there.
Yeah, you're right. It's related to the horizontal.
The one I always forget is the one that's like, what to do when they're the same. It's just the highest degree divided by everything.
Yeah, you take the number on the highest degree of the top and divide by the number in the bottom of the highest degree.
That's the highest degree. You don't have to do it for every other. degree.
No, just that one, just two terms, that's it. Okay. Without L'Hopital. 10 is really long. We'll come back to that. Let's see. $11. That looks more interesting. What's that?
They're all
Well, 10 is, we did recently. I think I'm gonna skip that. So remember when we graphed it, we found the
Sketching the curve.
sketchiness? Yeah, just, it's like 2 pages of nonsense. It's gonna be exactly like that example. The same thing. 11, more difficult stuff. Maximum, that's optimization. So rectangular sheet, perimeter 27. Okay. Of perimeter 27 centimeters. And dimensions X centimeters by Y centimeters is to be rolled into a cylinder as shown. Okay, so just picture them rolling that up to get the cylinder. Okay, that makes sense. Guess I can give it a little circle there. I don't know.
Sounds like a warning.
What's up?
It looks like this will come to a warning. Careful. It's scary.
This may give you an aneurysm.
Not so rare.
Okay. I couldn't see that. Let's see it. Let's see here. So since we're rolling this up, you see that the circumference needs to be equal to X. Does that make sense?
Yes.
And since we're rolling it up this way, then the side will be Y, right? I know they're not the same scale. I just can't draw.
Is that right? Right. It looks great.
circumference, whatever.
It's a good concept.
So picture you're rolling it up. Thanks. It's gonna be y.
I'll take it.
So it's as good as you're gonna get.
That video of the math teacher who drew a perfect circle with one spin.
Yeah, I've seen that. It's pretty, it's impressive. I don't think I'll ever be able to do that, but it's cool. Okay. Does the concept make sense? The drawings?
Yes.
They mentioned perimeter, so that tells me I should probably use perimeter. Did they mention anything else?
Dimensions are centimeter by y centimeter.
Largest volume. So what is the volume of a cylinder? Do you remember? Or can you logically make your way there?
Height times. Height squared.
Yeah, sure, if you want. I mean, you could derive it looking at this, but you could also Google it, sure.
It's gonna be the area of the circle, which is.
Yeah, if you find the area of a circle, just find out how many circles you got. That would be the total volume, right? Because you're basically, picture a roll of quarters, you're stacking circles. So you find the area of one circle times y, that would be volume. So yeah, you're right. Volume. What is the area of a circle?
Pi r squared.
So pi r squared times your height. Y. So what you Google, did they have pi r squared h or something?
Pi r squared h.
There it is. So even if we don't remember, we can sometimes figure these out. P, perimeter, it's two sides, two lengths and widths, right?
2x times 2x plus 2y.
There we go. All right. Perimeter was equal to 27, so I can solve for, let's see,
Plug in. Use that model for itself for a while.
well, hold on. What is the circumference of a circle? Formula. Call it C, I guess. Do you remember? A circle, that's area. Distance around a circle. That sounds right. I would think in terms of pre-cal, right? You go out your radius, and then you 2 pi go around the circle. So circumference, right? 2 pi r. What is circumference equal to?
X.
X. So we can replace the C with an X. So we actually have X equal to 2 pi r. Okay. It's a strange puzzle, but we'll figure it out. What is R equal to? I could solve for R, right? R is equal to 2 pi over X, right? Or is it X over 2 pi?
So 200.
So now we don't have to deal with R if we solve for it, because we could plug it in here. Yes. So I got X, got R, whatever. Let's solve for Y. So we got 27 centimeters equal to 2x plus 2y. Solve for y, that'll give me 27 centimeters minus 2x equal to 2y. So y would be equal to 27 centimeters minus 2x over 2. So I solve for r in terms of x, y in terms of x. So I can plug all that in here now, and then just do a derivative. So all of this nonsense was just to get it all in terms of one variable, because we have r and y here, and I don't want to deal with that. So I solve for y to substitute. Solve for r to substitute. Does that make sense?
Does all that have to be done before you take the derivative of the volume?
It's best to wait, because if you don't, then you're going to have implicit derivatives. And also, you'd have to pick dx, and there's no x here. What's that?
That's it, man.
Yeah, we're not done. We're not done at all. Your impatience was humorous. I'm glad you're excited. I'm glad you're really excited about this. See how this ends, right? All right, so plug in this guy. Plug in the y. I'm not going to write centimeter just because I have too much to write already. It is understood that this will be in centimeters cubed. Is that clear? Because we got centimeters squared times centimeters. And volume should be cubic units. All right. So now I got pi x squared over 4 pi squared times 27 minus 2x over 2. Multiply all that garbage out. This pi will cancel one of those, so that's nice. Distribute that x, and you're going to get 27x squared minus 2x to the third over 8 pi. Yes, it's pretty as it's going to get. So that's equal to volume. So now we can talk about derivatives.
27 times.
It's supposed to be a 2. All right. So the volume with respect to derivative of the volume with respect to x will be, what's 27 times 2? 54? 3 times 2. There's my derivative. Set it to 0. Running out of space here. (54x minus 6x squared) equal to 0. Denominator doesn't really matter. You can write it if you want. It's going to cancel. Factor x. Well, 6 goes into 54, right? Be 9 minus x. Okay. X equals 0. x equals 9. Obviously, there needs to be, it can't be 0, right? So x equal to 9 will give us, what do they want to get? Largest volume. So we were maximizing volume by choosing a specific x. That x that gives us the maximum volume will be 9. Basically say how thick do you want to roll up the paper or whatever. It's too skinny or too thick, it might mess up the optimization. Okay, so 9 is apparently a sweet spot for this dimension, the shape, or whatever material we got. The restriction we had, so whenever you're optimizing things in general, there's always a restriction on the problem, right? You'll have restriction on, let's say, time or workers or money or material. All those constraints force your problem to give you a specific x. So that x is corresponding to a limit of the perimeter of the shape of 27 centimeters. Okay. So just like we've been doing before in the other examples, you want to try to get into one variable. So when you have multiple formulas going on, the goal is to get it all to a single x or a single y or whatever. That's what we did over here. Okay. So I use a perimeter there to isolate y and substitute it over here. Right? I use the circumference to isolate r and substitute it there. Then I had no more r's, no more y's, one variable. And then we did the derivative. Is there any questions about this? It's a little involved, I guess.
When we took the derivative, where it says d of dv of dx,
Huh?
with respect to x. How come we use the quotient rule right there? Just not parentheses.
Because we do not have a variable down there. There's no x on the bottom. You could have done quotient, but it would have been unnecessary. It would have been long for no reason.
Find the y, we just plug it into the y that we found, right?
Yeah. Yeah, you plug it in, yeah, in there, it gives you. Did they ask for both? I don't remember.
We did so much, I actually forgot what we were doing.
Yeah, that happens. Yeah, it did say y, okay. Well, so I found the biggest x, so that will dictate the y. So y is equal to 27 minus 18 over 2. Let me show the plug in there. That's fine. So what is that?
4.5.
Oh, really? Okay. Yeah, 9/2. Any questions on any of the steps? I know that we were kind of got a little messy here.
Not why. For 4.5.
Or 9/2. I don't know what they wrote, but I guess we could check our answer, right? Pray a little bit that you got it right. Just kidding.
To be fair, I completely forgot what we were doing in the first place.
Yeah, they use 9/2. Whatever. Who cares? It's a warning. Just kidding. You guys cool on number 11? All right. Number 12 is applying the Newton's method. Do that in a second. So apply Newton's method to find the intersection of F and G. That's basically what they want. I don't remember what Newton's method exact formula was. Let me double check. There it is. Xn plus 1 is equal to xn minus f of xn over the derivative at xn. Okay. You guys cool on the question? I shortened it up a bit, so. What was the, did they give us an xn? A starting point. Guess not. Interesting. I feel like there should have been a picture here.
This is in the homework for 3.8 too. And it was really confusing,
This one?
something like that, the approximations that differ less than like 0.001.
Yeah, it looks like they want us to just pick our own xn, which is fine, I guess. Anyway, to find intersections, you set them equal to each other. Then you start applying the formula. Okay. So they tell us to use h of x equal to f minus g, which is equal to 2x plus 2 minus the square root of x plus 6. So the derivative would be 2 minus 1/2 times x plus 6 to the negative half. There's my derivative. I'm going to need for this value. I'm going to choose the number 3 as my xn. The only reason I choose that is because 3 plus 6 is 9. That will square root nicely the first time. Then this next time I'm going to have nothing but decimals. Can't get around it. I told me to do it twice in the question. So I'm going to do it once with a nice number that I choose. Xn will be 3. So that means that xn plus 1 will be 3 minus the function at 3 over the derivative at 3. So that'll be 3 minus, plug in 3 here, you get, let me put brackets because it's minus the whole thing. Two times 3 plus 2 minus the square root of 3 plus 6 over 2 minus 1/2 times 3 plus 6 to the negative half. I should probably use a calculator, but whatever. 2 times 3 is 6 plus 2 minus 3. 2 minus, so square root of 9 is 3 is minus 1 over 6. It's not that pretty, is it? So that will be 5 over, that's 2 minus the 6. Yeah, 11.
Over 6.
Yeah, 11/6. That's right. Okay. That'll be what, 30 11ths? This is like a pi, right? It's not a pi. Okay. That will be 3 11ths. Okay, well, whatever. What is 3 divided by 11? Yeah. They're gonna plug in that into here, so this is x1. So I should call this x0. This would be 0 plus 1. So now we're gonna do, so x1 is gonna be 3 over 11. So x2 will equal 3 over 11 minus f at 3 over 11 over the derivative at 3 over 11. At this point, we should probably use a calculator because this is getting disturbing. I mean, it already sucked to begin with. Right? Probably should have used a calculator here and just started rounding. But I have an exact answer. That's cool. Whatever that is. That should be our answer. Should be. Hmm. Hopefully this works out. If it doesn't, I'm just gonna go retire and go to sleep forever. It's fine. 4, 6. Cool. So this was 0.2727 forever, right? This became 0.25000. What was the question asking for again? When did it say we can stop?
If it's less than 0.0001.
Looks like we got it right. Maybe. Let's look at the answer. I already forgot what it was. Yeah, there it is, 2.5. So I picked my own starting point. You could have picked whatever you wanted. I picked something that I thought would be a little easier. Kind of was. Wondering if that was a better one, but nah. I don't think so. You can use a calculator right away if you want to. You don't have to do all that algebra here. It's up to you. It's whatever. Doing it this way gave me more accuracy. That was the only difference, but it was not necessary. Unless you're going to Mars or something. Just to keep it simple, right? We're just using a formula 2 times. That's all we did. Right? Get back to this in a second. H, didn't we? So when you set 2 functions equal to each other, or if you subtract them and set them to 0, you will find the intersection point. So since I subtracted them, I will find out when this is 0. The 0.25 is the intersection of F and G. If you graph F and G separately, you will see what I'm talking about. So visually, this is what it all means, right? The intersection point is 0.25, the X value. So we had 2 graphs and we wanted to know where they intersect. We subtracted them in order to take a derivative In order to use, I'm sorry. We have to remember, what does Newton's method do? Do you guys remember? Like, why did we subtract that? We're doing a bunch of stuff, so why are we doing this? Newton's method is used to find zeros, right? You remember? So, what's it?
Hard to articulate that stuff in English.
Yeah, it is. I agree. So Newton's method is an algorithm, an iterative method that will find zeros and will get closer and closer to your zero the more iterations you do. That's what it does. So if you subtract that, whenever the difference is zero, that's going to be the same as what these two are. And do you see why? Right. Intersection means they're equal, right? To each other. So you set them equal to each other, and then you subtract this guy over, then you have 0 intersection. So if this is 0, that's the same as when they're equal, which is the same as intersection. Let's all connect, right? It's all the same. So it's like a weird, it's like a roundabout way to find an intersection using Newton's method. So your calculator is using a lot of these algorithms in the background to find this for you. But to do it by hand, you do this. So before we had computers, crank out a bunch of calculations.
Okay, why am I getting your non-real calculation?
Or which one?
For the first calculation, I got, for when you did 3, we got -7. Now I'm trying to put -7 in there, I'm getting non-real calculation.
-7 is not in the domain. Because you'll have a negative in here. We look at the graph.
I'm not getting the same answers you got.
Right? The lowest number is -6. You can't go below that. Anything above it's fine. So you chose -7 just for fun.
No, because I got it from 3. That's what my card.
Three minus 2 times 3 plus. Oh, yeah, you forgot the -1/2 on the bottom. That might be it.
Oh, yep, that would be it.
See, I guess. I hope that's it. Any other questions on number 12?
Yep, that was it.
I told you to skip differentials, so. Don't worry about differentials. 13, 14, 15. That's all from the differential section.
That's full for me. Right?
I think so. I think so. All right, guys, we'll stop here, I suppose. So next time. Schedule wise. So on Wednesday, I'm probably gonna just move on to chapter 5. These two will probably be done in one day. 5.3 we're gonna skip. 5.4 is a pretty big deal, but we still have a lot of time. So I'll probably slow it down a little bit. Maybe do some practice problems with you guys. Chapter 5, we're only gonna have like 3 or 4 sections, and that'll be exam 4. And we got what? 3-4 weeks left. I don't know. I don't know what year it is anymore. So it looks like we have plenty of time.
I think we should say test scores as a group altogether.
We got to review for final. I guess we can spend a week or so on that. There we go. Yep. We'll use the time on that. Okay.